Well, here's your nudge video for MOP RL5 in the Refraction and Lenses unit. There's a few questions where you've got to organize a lot of information, and they'll give you some diagrams that I'm going to encourage you to draw on your own paper so that you can add some things to it. And here's an example of one of these. They describe two different media, one of which is a slow medium, that means that light would travel slowly through it, and the other is one in which the light would travel faster. And they're going to ask you in which one could total internal reflection occur if the angle of incidence was sufficiently large. So the first thing I'm going to suggest you do is to finish the diagram with the refracted ray drawn in. So I'm going to do that here in red, and it's all based on the speed of light through that particular medium as to whether the refracted ray would be bent towards the normal or away from the normal. So just as a reminder, and this is something you did a few MOPs ago, when light travels more slowly through a medium, then the angle will be bent more towards the normal than when it's in the faster medium. So here in this first situation, the speed in medium 1 is higher, and so as we go into the slower medium down below, medium number 2, then I'm going to draw a ray that's bent somewhat like that towards the normal. And then in the second figure, the slower medium is actually on top, and so we're going to be bent away from the normal. This is going to be kind of hard to draw, bent away from the normal. I didn't quite hit it there. I'm using my finger to draw. But something like that. And then in diagram C, we're going from the fast medium into the slow medium, because V1 is slower than or less than V2. And so again, it's going to be bent somewhat away from the normal like that. So they're asking, in which situation could you potentially have total internal reflection? Well, TIR can only occur if the refracted angle is getting bigger than the incident angle. And so there's only one situation here where that could happen, and in this particular figure it's diagram B. So if you draw in those refracted rays, then you'll be able to look and say, well, what's the possibility that I could refract so much that I actually go up to the boundary between the two media? And that's the point where you can sort of maximize your refraction angle at 90 degrees, and then after that you're not going to be able to refract anymore, and you'll have what we call TIR, or total internal reflection. So whether they ask like this in terms of the speed of the medium, or in some other questions they'll tell you something about the density or the index of refraction, and in either case you should have enough information to draw in the refracted ray, at least roughly, to figure out whether TIR is a possibility. So hopefully this was the nudge, get you over maybe the edge of what could cause you problems here. If not, come and see me for more individual help.